Founded in 1989 by the visionary Sir David Weatherall, the Institute was built on a simple yet profound mission to bridge the gap between basic science and clinical medicine.
David was a scientific visionary and he became a world leader really in molecular medicine. When the institute opened, it was really just one of a handful of institutes applying molecular biology to medicine.
We were sort of pioneers, and I mean not on our own. There were a few others around the world.
The neurologists played a really important role in the diagnosis of treatment of a debilitating neurological disease called myasthenia gravis.
We've spent a lot of time working on that disease. I've always measured these antibodies as a clinical service. I set that up in Oxford. People from Europe and abroad were sending samples to us for testing for various antibodies, and that became a big service, a big clinical service, which is continuing today.
Richard Moxon's work came out with vaccines for meningitis. When I had teenage children, I was really worried that they would get meningitis, which could be devastating in young people, often university age. And that really is now almost a thing of the past because of the fabulous vaccines that a lot of it came out of this institute.
My research has really been focused very much on Duchenne muscular dystrophy, a disease that affects boys. They go into a wheelchair in their early teens. Now they live into their 30s or 40s, but when I first started studying it, they were dead by 20. I was involved in mapping the gene, developing the first prenatal diagnosis with international collaborators.
Fairly early on, the WIMM pioneered the development of prenatal diagnosis for human genetic diseases, particularly thalassemia and sickle cell disease.
The standout highlight was Peter Ratcliffe's work that ultimately led to the Nobel Prize.
WIMM started me off, and it's the starting that's the most important thing in science. We found the oxygen sensing mechanism by working through a transcription factor called HIF. We worked out that HIF was regulated by a then unprecedented mechanism, prolyl hydroxylation, catalyzed by oxygen-dependent enzymes, and hence conferred oxygen sensitivity.
We set up the human immunology in the mid-1990s to bring together a number of groups who were working on human immune responses, which wasn't so common at that time.
Research that's emerged from the unit has led to the generation of companies such as Avidex, Adaptimmune, Immunocore and MiraBio, providing the next generation immune therapeutics for a range of disorders over the inflammation to cancer continuum.
The WIMM definitely provided the background for setting up Immunocore. Immunology was unbelievably strong there. Immunocore has been involved in changing the world's view on immunotherapy for cancer. If we go back about 20 years, it was really not considered something that could work. Immunocore's therapies work in some cancers where really there are no other treatments at all. So it's a way of specifically targeting solid tumours and activating the immune system against those tumours.
It has had its therapeutic implications, as might be predicted from low oxygen being a complication of most human diseases. So we have drugs that can work on the oxygenases that we discovered and inhibit it. That of course mimics low oxygen, and these drugs can be used and are indeed licensed for the treatment of anemia.
It's a really collaborative place to do interdisciplinary research. I work very, very closely with both basic scientists and also clinical scientists and other computational biologists, and it's really this melting pot of ideas from different sides that I think really makes WIMM a really unique place to do computational biology research.
These armchairs are precisely the right size, shape, depth to have a scientific conversation. Anyone who came to the WIMM, I immediately accosted them for knowledge as to how I might solve my own problem, and that was very important in many, many ways.
It was very supportive. Everyone was highly competitive, but very friendly. It was just a great community of people.
You can really take on almost any project you want in biomedicine here and find the right collaborators, find the right advice and find the right expertise. I can't think of many better places to do science than Oxford.